The following demonstration is for Nexio's BAT-EMC software. BAT-EMC stands for Benchtop Automated Testing, Electromagnetic Compliance. This demonstration is for the EMI option we call Automotive with bands. For this demonstration, we will focus on the Ford specification. Here we can see FMC 1278 is opened. In section 8 we have the requirements. We have table 8-1 for the level 1 requirements, and we have comments regarding the different detectors and the different limits and levels associated with each band. You can see that there's a band name, frequency range, and different levels. So what we have done is captured these parameters into our software, and I can show you the Nexio software. In this tab we have the equipment list populated. That is a requirement so that we can now have equipment setups populated. In this example you can see the monopole, which is the lower frequency range, and this is the equipment chain associated with that. Another important aspect is to show the administration tab license manager so that we know that these features are enabled. Here, for example, we have conducted current emissions, conducted voltage emissions, and then scrolling down further, radiated electric and radiated magnetic, automotive with bands. They're all selected. So indeed these features are enabled. If I go to the emissions resource section, you can see that there's a new area for limits we call automotive with bands. If I click on that, you can see the limits listed out individually for the different manufacturers. Just as before, when we do installations, we provide these limits, but we also train the customer on how to generate new limits or modify existing limits. Here you can see the two different groups, level 1 and level 2. You can see the band names, the frequency ranges, and so forth. Another aspect to discuss has to do with the definition of measurement time and frequency step size for the scan. These are not required, they're not mandatory, but they are useful because these values can be used in the future as default values. It's another example of time saving. With all of these things in place, we can now generate a project. I will generate a new project. I can give it a name such as the Ford demo. I will right click on it to add the equipment. I will give it a name such as example EUT for equipment under test. Right clicking on that line, I can now add an emissions test, automotive with bands, as distinct from the previous one simply called emissions test. So if I click on that, I can now right click on add the radiated electric emissions test. We can give it a name such as Ford demo, and we have the ability to use assistance or not use assistance. It is advisable to use the assistance because the software has intelligence built in. It can examine information from the bands chosen and the equipment setups and so forth in order to help guide future settings. I will now click on the Ford limit because that is the focus of this demonstration. I will select next, and all the bands in these two different groups are shown here. I have the ability to globally select all. I can select everything within a group or individuals. I will select all because the philosophy is to select as many bands as possible, test with all the setups that are possible for all the polarities and all the orientations in one go in order to increase efficiency and save time. I will click on next, and under this tab we have the setups. These are all shown as uncovered limit bands because we do not have setups associated with them. It is important to associate the right setup for each band, and if there are multiple setups possible, the software would prompt you to choose the exact one. We will start off with a lower frequency range using the monopole, and you can see that the list of uncovered limits has been diminished. I will click on another range, and now this list has been diminished further. Finally, the upper range, and indeed we have 3 different setups chosen which will test all of those bands. I can now click on Next, and we will look under the Settings tab. Allow me to resize this window, and you can see we have all the bands listed out sequentially. Under these columns you can see the various parameters. Looking at the mode, for example, you could choose between linear scan or FFT if your receiver happens to have the time domain scan capability. In this column you could choose to measure 120K instead of 9K for the resolution bandwidth. In this column it is already selected to measure the peak instead of quasi-peak, which is a time saver. If there was a failure, for example, you could always go back and remeasure using the quasi-peak. In this column you could choose to do an automatic remeasurement. Over here you can see the preamp is off, what the attenuation is set to, and I can edit an individual band. I can also use my shift key and select multiple bands and do a global edit, or a combination between shift and click to highlight all the bands that I know I'm going to do a global edit for. Another example of time savings. Now I can generate this test procedure. The procedure is shown here. Each individual band is listed sequentially. The state is shown here is not started. I could edit an individual band or multiple bands, and you can see these are the choices for the different parameters. So with that in place, I will now select Open, and we will soon be able to execute this test. Up above is the Start button. In order to execute the test, I will click on it. The block diagram appears for this lower frequency range, and this is the equipment setup, and this shows the measurement chain. I will click on OK and just simply follow the prompts for the software in simulation mode and allow it to do its testing. Now we are at the next range. For example, I have multiple resources here. I could choose to change an antenna if I wanted to. I will simply select OK and continue on. And over on the right hand side you can see the current state. We have some of them which are finished and they're grayed out. The box to the right is showing that it is finished. It is a green box with a check mark. Lower down we have a red box to show that it is started and in progress. Down below they are blue, which is not started. On the left hand side you can see a band name and a symbol. In this case it's a green circle with a checkbox. That shows that there weren't any failing peaks in that band. However, down below the G1 medium wave, it is showing a red circle with the X to show that there was a failure in that band. Another feature I can show at this time is that we have the upper window showing the current scan, and then down below what is shown is whatever is selected on the left hand side. So for example, this is the G1 band and it shows that we had a failure, and you can see the marker on the failing peak. Regarding the graph and the colors, etc., we have the ability to edit all of these. We have the ability to change colors and change size and various features for different things such as the traces and the limits. and we'll select cancel. Now we're at the upper range. I will select OK. Continue to follow the prompts. Above, we also had the ability to edit the suspects. You can see that we have a definition for pass-fail criteria. We could have also done data reduction, such as peak detection, and created an offset for the limit. I'm going to choose cancel so that we can allow the test just to continue. Another thing I can show in a moment when the test is complete is the ability to go back and do a manual remeasurement. In this case, we have the G1 medium wave shown here. I can also show the tabular view for the failing peaks. And what I can do when the test is complete is go back and remeasure an individual section of this span. So here we are on the final band right here, and the test is complete. So now I will select the manual mode, and as the software describes, select the frequency range on the chart and use shift plus click. So I'll use my mouse and I will shift over this area, and I can now select, let's say, number 1 and do a manual measurement. I won't change any parameters there. I'll simply just do a remeasurement and allow the software to do its remeasurement of just this highlighted range. And there you have it, the automatic test execution as well as a manual mode for the individual area selected here. I will close this test, end it, and now I can look at these results, which are summarized here. This was the original procedure under that tab. If we wanted to add follow-up information, we could define a table of things such as usernames or equipment names, etc. If there were external equipment, we could see them here. The used equipment is shown here. If there were attachments such as photographs or test setup diagrams, they could be added here. And once again, we're back to the results. I will right-click on this test in order to select the report generation. I will use that template as an example. Select Open, and I will give it a name such as the Ford Demo. Select Save, and the report is being generated right now. This shows a completed report. We have the header, various information, summary, tabular data, and graphic data. So you can see that this is a huge time saver. It greatly increases efficiency. And this concludes our demonstration. Thank you for your attention.